Okay, so now we're going to learn how to get the inverse of a 2 by 2 matrix. So if we start off with matrix A, which is going to be -2, 1, 5, 0, just as an example. The formula to get the inverse matrix for a 2 by 2 matrix is A inverse is equal to 1 over A times D minus B times C, all multiplied by the matrix D minus B minus C A. So what's important to remember is the order of the matrix. So in this case, with our A matrix, the A, B, C, and D represent the values at the points A, B, C, and D in that order. So, going back to our inverse formula, if we have A inverse here is going to be 1 over A times D. So A in our case is -2, multiplied by D, which is 0, minus our value for B in this case is 1, multiplied by C, which is 5. And then we can fill in our values to our new matrix as well. So we're going to start off with D, which is 0. Then we have minus B, which is going to be -1. Then we have minus C, which is going to be -5. And then we have A, which is -2. So if we start to multiply that out, we will have A inverse is equal to 1 over -2 times 0 is just 0, and 1 times 5 is 5. So we can turn that into -1 over 5 multiplied by our matrix. So 0, -1, -5, -2. And then we can multiply that out. So we will have -1 over 5 times 0 is still going to be 0. -1 over 5 by -1 is 1 over 5. -1 over 5 times -5 is just going to be 1. And then -1 over 5 times -2 is going to be 2 over 5. So in this case, the inverse of matrix A is equal to 0, 1 over 5, 1, and 2 over 5. Now, anytime you're asked to get the inverse of a matrix, there is a way to double check if you've gotten the right answer. And the trick is that the original matrix A multiplied by the inverse matrix should always give you the identity matrix. So for a 2 by 2 matrix, that is 1, 0, 0, 1. So we can multiply that out now to check. So if we take A times our inverse of A, remember our original A matrix was -2, 1 on our first row, and then we have 5, 0 on our second row. And then we want to multiply that by our inverse matrix, which we've just gotten, which is 0, 1 over 5, 1, and 2 over 5. So when we're multiplying together, we're going to multiply the rows with the columns. So we are going to have, in our first spot, we will have -2 times 0. So -2 times 0 plus 1 times 1. So that is our first row multiplied by our first column. So that's going to give us the first unit in our multiplied matrix. And then for our second spot, we're going to have the first row multiplied by the second column. So that is going to give us -2 times 1 over 5 plus 1 times 2 over 5. And then we're going to continue that for the second row of our matrix. So that is going to be our second row multiplied by the first column. So that is going to be 5 times 0 plus 0 times 1. And then our final spot on our matrix is going to be filled by the second row multiplied by the second column. So that is going to give us 5 times 1 over 5. I'll just fill in the brackets to keep it consistent. So 5 times 1 over 5 plus 0 times 2 over 5. And then if we multiply all of those out, minus 2 times 0 is 0, plus 1 times 1 is 1. So that's our first unit from this calculation here. Then our second spot is minus 2 times 1 over 5 is minus 2 over 5 plus 1 times 2 over 5. So they are going to cancel out. That's going to give us 0. Oops. It's going to give us 0. Then 5 times 0 is 0 plus 1 times 0 is also 0. And then our final spot, 5 times 1 over 5 is 1. And 0 times 2 over 5 is 0. So we just have our 1 from the 5 times 1 over 5. And that gives us our identity matrix. So that's just a way to check that the inverse matrix that we got up here is correct. You don't always have to check it. Sometimes questions will ask you to prove the inverse matrix by getting the identity matrix, in which case you would have to work it out. But otherwise, it's just a good way to check if you have gotten the right answer for the inverse matrix.